So the process that we're going to create is a debate process. So all we need for that is a prompt node. So in a debate, what are the steps of a debate? Well, you have one person who comes up with the um, pros for a claim, and then one person that comes up with the cons for a claim, and they sort of go back and forth and debate the finer points. And then at the very end, someone, let's say a judge, decides who won that debate. So let's come up with the first prompt. So we'll call it pros. This node comes up with the pros for an argument. And we'll have the input variable be a claim. The output variable, we'll call that pros. And then we've got to come up with a prompt, which is then sent to the large language model. So really the power of this system comes through two things. The first is input and output variables, and the second is the ability to nest processes within processes. But that's sort of a more advanced topic that we'll cover later. So for the prompt, let's just have, so come up with positive reasons for the following claim. And this claim right here is the variable claim here. So when we execute the process we're going to execute, it'll ask us to come up with a claim that will be sent to this prompt. So that'll make sense in a little bit. And the system, we're using OpenAI for the backend. The system sort of sets a context for the prompt. So in this case, we'll say, you are an excellent debater. Boop, and we create that. Now we're going to create two more prompts. One will be the cons. We don't really need a description. Again, we'll have the input variable claim because it's going to be working with the same claim previously defined in the previous prompt. And then we'll have the output of cons. So given the following claim, come up with a list of cons negating the claim. Okay, and again, we'll just have the system be, you are an excellent debater, debator, and finally we'll make the judge. And the description is just to understand what the prompt does later. So input variables. So in this case, the judge needs to know three things. He needs to know the claim. It needs to know the pros. It needs to know the cons. So the pros and the cons were come up with by the previous nodes. So they generate the pros and the cons given the claim. And the output variable will be decision and let's say reasoning. Okay, and here's where the magic happens. Given the following pros, cons, and claim, decide who won the debate and why. So now we'll just put this in here, claim, give it that input variable, cons, give that input variable, and pros, again, give it that input variable. And the system, the context that this prompt gets is you are an excellent judge of reasoning and logical fallacies. Now, this doesn't ensure that this is true, but I don't know. I like to think that it helps the language model do better. Um, OpenAI claims it does, so we'll assume it does. Okay, now we want to create a process. Um, and for this process, we'll say debate. That will name it, yeah, debate. And this is a debate about a claim. I don't know, just that can be anything, doesn't really matter. And these are the prompts that we came up with earlier, so we'll put them in there. And saving the process sends the process to the backend. It will decide how to construct a dependency graph based on the input and output variables of these prompts, and then it'll come back and display it here. So there. In that split second it did that. Very cool. Go Rust. And now we want to execute this process. So we've got the debate. That's what we named the process, and we'll have the claim. The sky is blue. Okay. Again, we submit it. Sends it to the backend. And chugs away. So I'm not a graphic designer. It doesn't show anything loading here. That would be a relatively easy fix. But for the time being, we trust that the backend is working. Okay, so let's see. We're at the pros claim. Now we're at the judge claim. And very shortly, it's going to send the result of these prompts back to the front end, and there we go. The system decides the order, and it decides the order based on the dependencies described here. So because the judge prompt relies on the pros claims and cons, the backend determines that one of these has to be executed first, then the other, and then finally the judge. So it decided, let's run the cons first, then the pros. It like linearizes, I don't know, the graph. And so the prompt that it put the variable in for is, given the following claim, come up with a list of cons negating the claim. The sky's blue. So it comes up with a list of cons, and then the that's a bug. This should go all the way down there. That's a moral failing on my part. Anyways, maybe I'll cut that out of the video. Okay, comes up with the list of pros, and finally the judge comes up with the decision of who won. So list the cons, list the pros, and it comes up with the decision. The cons won the debate, meaning oh, okay, so it decided that the sky appears blue to the scattering. So it decided the sky is not blue, and let's see its reasoning. Okay, so that's some pretty good reasoning. This is actually very interesting because it's a large language model, it won't always come up with the same decision. The judge won't. One way around this is using the tree of thought. Running this multiple times and then deciding or just counting the number of who won the debate versus who lost the debate, and just sort of tallying them and going with the more often chosen result. Okay, so that's an example of the pros and cons like debate process executing. So like I said, the power of the system comes from input output variables, and then also also the nesting of processes. So let's show the nesting of processes. So let's come up with a new prompt um, where we can demonstrate that. So this new prompt will be wild claim generator generates a wildly conspiratorial claim. We've got the input variable of blank and the output variable of claim. Okay, come up with a wildly conspiratorial. Okay, there we go. I think I spelled tutorial. Okay, wild conspiratorial claim, and then just because we need it, we'll put the blank input. Be wild. Okay. Okay, so now how do we nest prompts within, or processes within process? We go here, and I've actually never done a process within a process, I don't think. So this is testing a new part of the system that just theoretically should work. So yeah, wild claim debator. Anyways, generates and debates a wild claim. Okay, so what do we need in this? We just need the wild claim generator and the debate process. We save that. And perfect, the system was able to determine that we need to generate a wild claim and then have the debate based on that wild claim. And again, that's because this wild claim has the output variable of claim. This one has the input variable of claim. So now we want to execute that and see if this works. Return the result from the back end onto the front end. So let's see. So the wild claim generator came up with world governments are controlled by ancient society of whatever. I'm not reading that. That's fun. Okay, maybe I'll read it. Cartographers. What, map makers? Global virtual maps to conceal the essence of... Oh, wow. So there's a special continent that has unlimited clean energy. Okay, sure. Then we come up with a list of cons, lack of concrete evidence, technology, transparency. Oh yeah, we would just see, see them, right? Okay, so the pros, let's see. Preserving, come up with positive reasons. Oh, okay, so this is actually sort of a problem with my prompt. I should have said supportive reasons, because it's coming up with reasons why this would be good. So this is why, it's important that this is part of a, when you're coming up with processes, they should be tested out, and you should try to generate a process, then see the results of executing it before you nest them. So the reason you would want to test a process thoroughly before nesting it is because you can go infinitely deep within process nesting. If one of the dependent processes, that is a process that runs deep within another process, produces outputs that you don't expect, the system can produce garbage. Going down to the output of this debate, as we would expect, the cons 1, meaning that, yeah, this is not a very likely claim. And the reasoning is the cons present a strong case rooted in practical and veritable evidence that contradicts the claim, of course. And pretty much any time we run this process, the cons should win.